We're doing example 10, chapter 6, involving confidence intervals and the interpretation of confidence intervals. This is chapter 6, number 10. Let's see. Where's the problem? Here it is. Okay, so we have data involving two variables, I believe. And this time I'm going to open it up in StatCrunch, which I believe is going to be easier for this particular problem. And here's the data. We have really one variable with numerical data. There are actually 20 observations. And they want you to find a 95% confidence interval. And that's readily done by hitting on stat. We want a t-stat because we don't know the standard deviation. We're going to estimate it based on the actual data, which is a more common case. T-stat. We have one sample as opposed to two or more samples in later chapters, and we have the actual data. We want years of service, a numerical variable, and we want a confidence interval, and we want a 95%, which is the default. Compute, and it's 9.72 right here to 16.47 right here. That's easy. Now comes the next part, which is to interpret it. Let's do that. So, what does it mean to be 95% confident? And again, I keep saying this, but again, this is not really in lieu of lectures. The lectures are really done in the YouTube videos. But I'll say briefly what's happening. It means if we would repeat this process of taking a sample of accounting professionals and getting their average, and then calculating a 95% confidence interval, it would cover the real answer. Now, we don't know the real answer. That's why we're doing this study. But if you theoretically, if you got every single accountant in the world and you calculated the true value of all millions of accountants' year of service, let's say it comes out to, I don't know, 12.5. So if we keep repeating this process of taking 20 accountants at random, getting an average, calculating the interval, 95 out of 100 of those intervals that we create will cover the true value. Now that's a mouthful. And again, I explain it in much more detail in the video. But in terms of the multiple choice, we are 95% confident that the population mean will be between the confidence intervals. That's a little bit debatable, as I wouldn't even accept that as the right answer, but it's the best of all the answers. Not 95% chances between the intervals. 90%, it's not this one. No, it means that if we repeat the process 100 times, we're going to cover the right answer 95% of the time. So let's see, we're 95% confident the population will be between the confidence interval. Yes, so I guess you can say that since if we did this 100 times, this is just one among the 100, we're 95% of the time this interval will cover it. So there's a 95% confidence. So I would say that's the interpretation of why B is the right answer. Now they want you to do it only for those with a graduate degree. So go back to StatCrunch, which is somewhere. We want it to be the graduate degree, only the graduate degree. So we can do it a couple of ways. Let's do it by stat. Again, t-stat, one sample with data. But this time, we're build group by, this is an easy way to do it. Group by graduate degree. So we're going to get two separate answers. One for those with a graduate degree and those without. We could have theoretically did it this way, say where graduate degree equals exactly yes. But since we only have two categories, let's do both of them. And for the yes, it's going to be between 7.23, which is right here, and the upper limit, which I just saw, was 15.76. 15.76. Check answer. No. Again, you see, I don't read. We're looking for the confidence interval, not on the mean, not on the averages, but on the percentages. Oh boy, this is a whole different explanation that's required. So let's make this numbers wrong. It's going to be a percentage. Oh, okay. So now we have a percentage. So I take it back. Let's go back to the data. And so this is totally irrelevant. We now want a focus on this column, stat, proportion stats, one sample with data. And we want graduate degree. Success is going to be a Y, which means which is found in that column. Let's show it to you again. Where is it? See it? It's there somewhere. Anyway, let's try it. And we want confidence interval 95 degrees, 95%, method, walled, compute. So it's saying that 40%, and it's 40% of the people in the sample out of the 20 have graduate degrees. We can calculate, we can copy this over. And it goes from 18.5%, 0.185, up to 0.614. Now I have to explain this, 0.614. Before I start talking, let's check it. Yes, okay, so let's go back to this, how you solve this. What we're saying is if you calculate all those different yeses and nos, 40% of them are yeses. I don't want to count them up, but it's going to be 10% will be what? It'll be 8 out of 20, 40%. But that's just in this sample. If we took another sample of 20, we might find 10 out of 20 or 50%. Or we took another sample, we make it 15 out of 20. So it's going to vary from sample to sample, and the confidence interval tells us we're 95% sure the real answer is somewhere between 0.185 and 0.614. That's what it's saying. So let's now interpret it. There's a 95% chance we're 95% confident the population proportion, whatever it is somewhere between these numbers. Because if you repeat this again 100 times, each time you get a different sample with a different average and a different high and low number, but 95 of them will cover the unknown value. So I believe that's the answer. And right. Okay, guys, I hope that helped. Stop sharing. Bye.